Welcome to Solving Rational Equations, Part 2. This is Method 2. Solve the equation by using the least common denominator. So to solve using Method 2, first factor the numerator and denominator of each term and reduce within a fraction if possible. Second, you're going to find the lowest common denominator of all the fractions, and that's the reason we need to factor. The lowest common denominator, I'll put it right here. So the least common denominator is the product of all unique factors the number of times each factor appears. Within an expression. So, in other words, it doesn't matter if there are 3 terms that need an x. If nobody needs more than x to the first power, then that's all we'll need. Right? And once you see how we determine the least common denominator, I think you'll get the hang of it. All right, so then we're going to solve the resulting equation, and then we'll check all solutions. This method can be used to solve any rational equation. You must use this method if there is more than a single rational expression on either side of the equation. If anything is added to our rational expression, it could be just a plus 1. Right? We have to use this method, not cross multiplying. All right? So let's see this method in action. With this problem, so we have 5x divided by x minus 1 minus 2 equals 14 divided by x squared minus 1. All right, we got a minus 2 with it. Right? This is 2 terms. One term is 5x divided by x minus 1. The second term is the negative 2. So we must solve using least common denominator. So first we're going to find our least common denominator. This is an easy factor because this is a difference of squares. So there's nothing you can do to factor the 5x or the x minus 1. Right? Nothing you can do with the 2. But the x squared minus 1 could be factored to square root minus square root plus square root. Right? So x minus 1 times x plus 1. All right, so the least common denominator, let's figure out what we have in the denominators, the unique factors, and then we'll see how many times each occurs. All right, so in our first expression, the denominator is an x minus 1. So I definitely need a factor of x minus 1. In the second term, the denominator is 1. Right? It's just an integer. Any integer value could have 1 as its denominator, right? Because 2 divided by 1 is still 2. So we don't need the 1. The third expression has in the denominator x minus 1 times x plus 1. Right? So now I need 1 x minus 1 and 1 x plus 1. I don't need 2 x minus 1s because there's no fraction here that needs 2 factors of x minus 1. Right? Nobody needs more than 1. So the least common denominator is going to be x minus 1 times x plus 1. And actually that's what I have right here too. So now we're going to multiply each fraction by the least common denominator, by x minus 1 times x plus 1. All right, every single term. Right? Don't try to distribute, just give every term an x minus 1, x plus 1. It'll be so much easier. So, whoops, need the x there. So we have x minus 1 times x plus 1. So we got to multiply the 5x divided by x minus 1 by that. And then I'm going to write this as plus a negative so we don't lose that subtraction sign. All right, so then we have plus x minus 1 times x plus 1. And we're going to multiply that by negative 2. See, if I put the negative 2 there, I'm definitely not going to lose that negative 2, hopefully. And then we have equals, and then I've got to multiply the 14 over x minus 1, x plus 1 by x minus 1, x plus 1. All right, so every term got multiplied by the least common denominator. And what that's going to do is that's going to cancel out our denominators, which is great. Then we'll have something polynomial that we can solve. So here, the x minus 1's cancel. On the second term, nothing cancels because the denominator is just 1 on the negative 2. And in the third expression, everything cancels. All right? The entire denominator cancels out. All right? And you should have no denominators when you're done canceling. Right? If you have the least common denominator, the entire denominator should cancel out of all terms. In this case, though, we canceled out the entire least common denominator too. All right, so now we're going to rewrite this, right, so that we can distribute. So now we have 5x times x plus 1 plus, well, I couldn't do much with this, negative 2 times x plus 1 times x minus 1 times x plus 1. And then equals 14, because everything else canceled. All right, so now we're going to multiply. All right, so 5x times x will be 5x squared. 5x times 1 will be 5x. Now, if you've got to distribute a constant term, a scalar multiple, to a product of binomials, take care of this first and then distribute the negative 2. That'll be a lot easier. And actually, we know this is a really easy multiplication, x minus 1, x plus 1. Because if you remember, we factored x squared minus 1 and got x minus 1, x plus 1. So I'm okay if we write plus negative 2 times x squared minus 1. Because we know that's what we're going to get if we multiply out x minus 1 times x plus 1. Right, and then we have an equals 14. All right, so now just distribute the negative 2 and combine like terms. So we have 5x squared plus 5x, right, minus 2x squared plus 2. Right, so that's why it's really important to make that a plus a negative 2 so we don't lose that negative sign. Because otherwise our answer is going to be wrong if we make errors in computation. All right, so we can combine like terms, and we know that to solve a polynomial, we're going to have to set it equal to 0. And in this case, we're going to be able to factor. So at the same time as we're combining like terms, why don't we subtract the 14 from both sides? So we have 5x squared minus 2x squared. That's going to be 3x squared. And then we have a 5x. And then 2 minus 14 is going to be negative 12. All right, and now 3 times, so actually I'll write it in. A is 3. And C is negative 12. And of course B is the coefficient on x, it's 5. So 3 times negative 12 is negative 36. We need two numbers that multiply to give us negative 36, but add to give us the b term of 5. All right, so well that's going to be, so they've got to be opposites. Well, 9 times 4 is 36, right? And if I make the 4 negative, then it'll add to 5. Right? So when I think of it, I just think of which factors of 36 are 5 apart. Well, that's 9 and 4. Right? And then you just make sure your signs match the information that you need. So we keep the 3x squared. Let's replace the 5x with a positive 9x and a negative 4x. Remember, the negative goes with the 4x. And then negative 12 stays. And then the first two are a group, second two are a group. pull out the greatest common factor. I say so. The greatest common factor for 3x squared and 9x is the 3x. 3x squared divided by 3x is x. 9x divided by 3x is 3. Greatest common factor for negative 4x and negative 12 is a negative 4. Negative 4x divided by negative 4 is x. And negative 12 divided by negative 4 is a positive 3. So now we can factor out that repeating x plus 3. And we're left with 3x minus 4. So now we'll set those equal to 0 and solve for x. Oh, I'm starting to run out of space. I just need a little bit of space. I wonder if I could. There we go. There, I got a little bit of space. So if x plus 3 is 0, x is negative 3. And if 3x minus 4 is 0, so you'd add 4 and divide by 3. So x is 4/3. And yes, we can check a fraction in a rational equation. Right? So it's okay. It's not a bad solution just because it's a fraction. Right? And I'll show you how to check those. Let me just move everybody up. And I don't know if this is in your notes because I don't have the notes in front of me. So I don't know. But I'll tell you when we're watching the video. I can do that. All right, so now we're not quite done. We've got our solutions, but are they good solutions? Right, we have to check. Now, we didn't cancel anybody out, so there's nobody we have to worry about that way. We just have to check if these solutions are good. And actually, let me put the screen up so I can go over one thing at a time. All right, let's move this over. And if it is in your notes, it's got a check that's all typed up. All right, so x equals negative 3 was 1, and the other one was 4/3, I think. All right, if I move my recording box, the thing you can't see, yes, 4/3 was the other one. All right, so we plugged in the negative 3. We got 5 times negative 3 divided by negative 3 minus 1 minus 2 equals 14 divided by negative 3 squared minus 1. So now these are a little bit trickier because you got to combine like terms and all. So we simplify that. We have negative 15 divided by negative 4. You can cancel out the negatives. Now, I can only combine 2 with 15/4 if I change 2 so it has a denominator of 4. So if I want the denominator to be 4, I have to multiply the numerator 2 by 4. All right, so now we have 15/4 minus 8/4. That equals 14/8. So on the other side, we have equals 14/8, right? So 9 minus 1 is 8. Now, 15/4 minus 8/4 is 7/4, and 14/8 reduces. So 14/8 reduces to 7/4. So that solution checks. Negative 3 is a good solution. Let's look at the other one. It's a little more complicated on the check, but not really once you simplify it out. I mean, it looks a little bad in the beginning, but really it's not that bad. All right, so we have 5 times 4/3, and I rewrote that 5, so it was, it was a fraction. It just makes it a little easier, I think. Divided by 4/3 minus 1. Well, I can't combine 1 with 4/3, so we changed 1 to 3/3. Minus 2 equals 14 divided by 4/3 squared minus 1. So we just substituted 4/3 everywhere. So 5 times 4/3 is 20/3. 4/3 minus 3/3 is 1/3. So you've got 20/3 divided by 1/3. But dividing by a third is the same as multiplying by 3, right? So dividing by a fraction is the same as multiplying by the reciprocal because multiplication and division are inverse operations. So I just changed the 20/3 divided by 1/3 to 20/3 times 3. And we still have the minus 2. I'm just letting them hang out until I simplify the other parts, and maybe I won't have to do anything with him. Equals 14, and then we have 16/9. That's what 4/3 squared is. And I need to change that 1 to 9/9. So now we have 14 divided by 7/9. And dividing by 7/9 is the same as multiplying by 9/7. Well, 14 times 9/7 we can reduce. Right? So 7 divided by 7 is 1. 14 divided by 7 is 2. That gives us, and so let's go back to the beginning. Let's go back to right here. All right, so we have 20/3 thirds times 3. The 3's will cancel. That's just 20. 20 minus 2 equals 14 times 9 sevenths. All right, we can reduce, and that gives, we're left with 18 equals 2 times 9. And I think it's off the screen, but it just says 18 equals 18. This solution checks out. So these are both good solutions. So even though it looks a little funky, 4/3 is a good solution. All right, so in the next videos, you'll see me solve some more problems, and some of them are in your notes and some of them aren't. But we'll do lots more examples together. Thanks for watching. Bye for now.